അവന്റെ ടി പി നോക്കിയായിരുന്നോ?
ഇല്ല, നോക്കിയില്ല.
ടി പി തന്നായിരുന്നെന്ന് പറഞ്ഞു.
അന്ന് തന്നായിരുന്നു, അത് ശരിയായില്ല.
ശരിയായില്ലത്.
നാളെ വിളിക്കാം ഞാൻ. ഞാൻ നാളെ അവിടെ പോയി ശരിയാക്കാന്ന് പറയാം.
അന്നേരം ഒ ടി പി വേണ്ടേ?
വേണ്ട വേണ്ട,
ആ,
അത് ആ ഫോട്ടോ മാത്രം ശരിയാക്കിയാൽ മതി. അഡ്രസ്സൊക്കെ കറക്റ്റാ.
അവന്റേതോ?
Hello, good morning everyone.
Good morning, everyone. Can you hear me?
Good morning. Yes, you are
Good
audible,
morning. Good
sir.
morning. Yes, we
Yes,
can
sir.
hear
Good
you.
morning, sir.
Good
You are
morning.
audible, sir.
This is MM Mehrotra. We will be discussing on MEP services in large buildings, right? My name is MM Mehrotra. I am retired chief engineer from Military Engineer Services. So I'll for 1 hour 20 minutes I'll be discussing my subject. Then 10 minutes we'll keep for some discussions on questions from your side.
Okay.
Right?
Okay.
Okay. First question is why MEP is required. Firstly, what is MEP? Mechanical, electrical, and plumbing. So, plumbing I will not touch because that is primarily a civil engineering subject. I myself am an electrical engineer, so we will concentrate more on mechanical and engineering, electrical engineering services in a building. Now, why MEP is required? You must be able to see on this slide. Any building, we go to a mall. It's a big building full of activities. Now you simply switch off all the lights, heating, ventilation, lift, escalator, power supplies, firefighting, security, everything. Now it's a dead building. You just can't enter, you can't breathe. You can see a beautiful building, but it is useless for you. So unless and until MEP buildings, MEP services are there, buildings cannot be made to use. Now these are the some items which I'll be discussing. Firstly, some basic concepts which that everybody knows, but I have deliberately kept two slides on this just to recap what you do. Because in practical world things are little different what we learn in theory. So the in this sequence things will be coming. I may not be because 1.5 hours is too less a time. This discussion can take place in entire day. So I'll cover whatever is essential. Next is now some basic concepts. All of us have read electrical in our 12th class graduation everywhere. You can see a PowerPoint here. PowerPoint one whole is for line and other one is for neutral. Line and neutral, right? So when we say it's a single phase, we first thing comes into our mind is a PowerPoint like this. When we say three phase, then there will be three similar PowerPoints like this connected to different phases, right? Now each phase, if I see this point, this is my base, this right side point is my line. If I put a voltmeter here, the voltage will increase from 0 to 220, then it will come again to 0 minus 220, like that it continues. So one frequency is 50 hertz, means in 150 milliseconds this cycle is getting repeated, right? Now a three phase system will have similar thing, but will have three similar patterns. Now next is how this is affecting our services. Now here you see on the top there is a electricity source. On the right hand side is the load. Then there are two wires. One is connecting from source to load, and return wire connected from load to source. Now this is from this figure what we can find out is whatever current is going into this load is also coming back from the load, and circuit is being completed at the source. That means top and bottom conductor will have identical current, so they should be of identical size. Now, in a single phase circuit, line and neutral conductor will always be of the same size. For your information, there is an earth conductor also. This earth conductor is normally half the size of the line or neutral conductor. Means if my line conductor is 1.5 square mm, so the earth conductor should be 0.75, but no, IS says it will be minimum 1.5. So in our normal house wiring light circuits, all the wires which you will see will be of 1.5 square mm, right? Now come to the bottom figure. Bottom figure is three phase may, in this, these three loads are there which are connected in this fashion. The star point where the one here, the bottom one is replaced by this star point. Now the neutral in a three phase is carrying the current vector sum of these three phases current. Vector sum will be, if all these currents are equal, then this current in the neutral part will be zero, right? So here in this neutral conductor, minimum current will be zero, maximum will be much less than full load current. So it will be some vector sum, it will be 20-30% of the normal current. If the circuit is unbalanced, things will change, right? When this current will increase in the neutral conductor, when these three phases currents are unequal. When these are unequal, there will be some resultant current into this. So now consider a three-phase cable. Three-phase cable, you must have seen that there are three conductors which are of equal size. Then neutral is half the size. Why half the size? Because it is required to carry 20 to 30% of the normal current. So hence it is of smaller size. So in case of single phase, neutral conductor is of the same size, and in case of three phase, neutral conductor will be half the size, right? Is this point clear to you? Can you hear me?
Yes,
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 yes.
Yes,
Yeah.
sir. Yes, sir.
Any doubt you can ask, or you can note down in question answer session, we can talk, right? So
Yes.
this
Okay.
I deliberately keep it because we have a tendency to forget the basics. So here I have differentiated between the size of a neutral conductor in single phase circuit and size of neutral conductor in a three phase circuit. Now let us come to external electric supply. How supply comes to our building? It is coming from utility, from overhead lines. So now this thing is coming to our switchyard. Switchyard, say from switchyard the supply goes to a metering box. First thing is that utility will ensure whatever electricity they are sending must be charged. So first thing we will get is a meter. If there is a circuit breaker, that breaker is not in our control. It is in the control of SEB, that supply utility company, right? Then from this metering box, supply comes to HT panel. HT panel, you can see on the left hand side there is a panel. Here actually it's only a control panel. Here the HT supply is not flowing here. This you are seeing inside your substation, but actual components which are having HT supply or current are in your switchyard outside where your transformer is there. Now Supply comes from there. This is control panels. HT supplies goes into transformers, right? Transformer HT converts it into LT. Now LT supply will come to my LT panel board. Here we have with different circuits going to different locations in my building, right? So this building can be a multi-storied building. This can be a single-storied building having different. Suppose it's a hospital, it will have 10 wings. So every wing will have some separate control. At the same time, we also have DG sets for our standby supply. Now DG set will get connected somehow with these LT panels, because DG set is also on LT, creating same 415 volt, right? So that DG set supply will get connected parallelly with SEB supply. How, we'll see later, or it is not required at the moment. Now supply from this goes to different LT circuits. This here, the distribution what you are seeing is what we see normally in our homes, right? So these are MCBs. They should be neatly connected in the distribution board. I will come to it little later. From here, the supply is going to different loads. Loads are my lights, fans, or now power points or things like that. Now here you can see this distribution board is some wires are going out. Now some wires are going out. Each wire has got a circuit. Circuit is having 6-7 light or fan fixtures like this, right? So I will repeat. From utility company I get HT incoming supply, as you see this from the tower like this. Then there is a small switchyard in my premises. Premises will have a switchyard which will house this transformer. So the supply is coming to a component like this, going, that control is here. It is only having that 415 volt or 220 volt only. If I touch this, nothing will happen to me. But if I touch this, something will happen to me, right? So this is going to from transformer, it is going to LT. There will always be a circuit breaker at the incomer, right? And then there will be outgoing circuits. Then DG set is there, which is connected to this LT panel. It will provide supply whenever electricity supply from SEB is off. Now from this distribution board will be there, which will take my supply to these points. So from each wire is equal to one circuit, where 6, 7, 8 or 10 light or fan points will be connected. I'll proceed further. Then there are two more components here: APFC panel and UPS. APFC is automatic power control factor control panel. Power factor, I will not discuss what it is, but if it is provided, then that utility company will not impose any penalty on us, because this affects the utility company, not to me. Now, there is something called UPS, an uninterrupted power supply. You must be using a UPS with your computers. There is a similar kind of a setup in a building which will provide in case of emergency. Now here I will mention what happens if the supply goes. Supply goes, there is a panel which senses that SEB supply has gone. So it will command the DG set to switch on. So there is a system, but it will take about 8 seconds for the supply to get stabilized. That is why you must have noticed, if the supply goes and DG set supply is there, it takes some time to come. So that time is when the DG set is gaining speed and producing voltage as required by you. Now, UPS is there to provide supply during that intervening period, right? So intervening period, this supply will be given by this UPS. UPS will also provide supply to some security like CCTV system is there. So that has to be operable on the time, all the time. So for that UPS has been provided. Now next is this you must have seen. I will not discuss it in detail. I will only mention the components which you have seen. Here, if I start, can you see these two circles? These are transformers. This is circuit breakers. The supply is now forget this. This will be too complicated for you. Now you must have seen that distribution board. That equivalent is here. Here the supply is coming. This is the phase. This is the circuit breaker going to different rooms. Now each circuit has got different type of loads. Next is earthing. Earthing, this only you see this figure. Earthing word is important. Earthing utility, there is a lot of utility of this earthing. Here, what you do, you provide an earthing for the safety of the personnel who will be using this building. One thing I just forgot to ask, all of you are civil engineers?
I'm electrical engineer.
Electrical, sir.
For electric and mechanical, there'll be something repetition, but since it's a mixed crowd, so I have tried to include some basic concepts. You just simply revise it, right? So earthing is something buried in the ground. It is taking fault current into our mother earth, right? If it is not there, then this energy will go somewhere else. It may go into my body, it may go somewhere else where it will burn the thing or kill a person. So to divert that energy we need earthing. Now next is, we have seen that photo of DG set which is connected in parallel with that panel. Now, earthing I just mentioned. So, for the safety of the system, we need earthing. Earthing, where all it will be used? It will be used in my electric system, where earthing is there in the panel. Panel body is earthed, but transformer generator set are the electrical machines. When it is electrical machine, there will be two different earths, one for neutral, one for the body. My panel is not a machine, it is just a body where supply is coming and being distributed further, right? Now, yeah, nowadays no generator comes bare. They are always inside this acoustic enclosure, right? So and even then ventilation is very crucial. Now I can keep this DG set outside and open, or I can keep this in the basement of my building. I am concentrating more on a multi-storied building having say 50 or 100 houses having 20-storied or whatever. Now this ventilation is very important. If it is outside in the open, ventilation is taken care of by nature, but inside there'll be lot of exhaust fan and other things will be needed. Now this thing is put on a concrete foundation, stable concrete foundation. Load testing is little complicated. I'll leave it. RECD, these days this RECD is coming into discussion. Retrofit emission control device. As in case of vehicle, you must have seen India pollution series 4 number, 5 number, 6 number, like that. Similar pollution control norms have been put by the government, but these generators will not technology will not change overnight. Factories will take time to create engines which are compliant with the norms, government given norms. So for the intervening period, you need to provide RECD, retrofit emission control device. This will ensure that output from your generator is conforming to government regulations, like different types of this thing. But without this, the that licensing company will not allow you to energize. Next is DG said these are common precautions which should be there. As I said, this it creating lot of heat, so there must be enough ventilation available in your DG set room. Now we had seen that panel. From that panel, supply comes. Now I am an MEP engineer. I am an electrical engineer. Project is predominantly managed by civil engineers. So they are not bothered what is happening to your electrical mechanical things. So when this casting is being done, MEP engineer is required to visit first to the site. When the shuttering is being fixed, that time that reinforcement is being fixed. That is the time when fan hook, conduits, different points, these things are fixed. So there will be some possibility of plus minus here and there, but fan hook will not change. It is connected to your reinforcement which is inside the shuttering. So this is unpardonable mistake. It happens in any construction. It happens. Now next is conduit. That conduit, you see that there are many wires inside it. So there will be power wiring and light wiring. So same conduit should not carry wires connected to power point and wires connected to light point, for the obvious reason which you understand. Same thing, I told you 3 phases. So the 3 phases can be provided in a house. One phase connected to one house, or and if there are 3 houses, so 3 houses will be connected to RYB in cyclic manner. Or sometimes within the building you have a 3-phase distribution where supply will come in different phases, so that if the fires of different phases are available, same conduit should not carry supply of different phases. Now next is color coding. Color coding, and next figure you will see what is color coding. Color coding, all those who are electrical or maybe mechanical are aware about the color coding. You know RYB, red, yellow and blue. So these are the colors provided to the wires also when we do the wiring. Now this is the distribution board. This is a single phase distribution board, where here it is somebody has put this. I've taken this figure from the net. So, but it is color codes here are not mentioned, but here I have put it for the sake of seeing the neatness of distribution board. When the construction takes place, this distribution board carry wires which are connected in a very haphazard manner. So they should be neatly connected. Here it is the color code which I was mentioning. Now this is the utility company which is giving us the supply. Here the metering panel. Metering gives supply to our incoming MCB. Incoming MCB goes to this, from this supply goes to your distribution board. Suppose this distribution board has got 8 outlet circuit. So now in that distribution board, you will see 8 outlet. These are live wires. These are neutral wires. They are connected to a common link. Each live wire is connected to an MCB, whereas these neutral wire is connected to a link. Now in a distribution board, if it is 8 circuit distribution board, you will see 24 wires. 24? 8 line, 8 neutral and 8 earth. So each circuit will have a separate earthing. Tendency of workmen on ground is to take loops from different earthing circuit of one room to other room. But if there is a circuit, light circuit, that earth wire also must be terminated into this distribution board. Next is your fire alarm system. Fire alarm system is something similar to our electric wiring, but here these are
હવે અમારે છે ને ઉંમર થાય ને એટલે ગમે તેમ કરીને જિંદગી જીવવા હાટુ દિલ ખુશ રાખવા હાટુ જિંદગી જીવવી પડે. એવું
any
કામ
doubt,
છે.
ma'am? Okay. So in a fire alarm system, why a fire alarm system is provided? It is not to fight the fire, but tell you that there is fire somewhere inside the building. So it only raises alarm. It does not fight fire. It only tells you there is a fire somewhere in the building. You act. So some components I have written here. First is manual call point. You must have seen there's a small square shape point which is available in all buildings, all malls, all this thing. But where you say in case of fire, break glass, it is written. So there is a button which is there in pushed form. When you break the glass, that button comes out and it raises an alarm. Alarm is some hooter or siren which is gets activated by this. Then there are smoke detectors and heat detectors. Smoke detectors will sense the smoke. They are optical in nature. If they see smoke, that optical quality deteriorates and they operate. Heat detectors are seeing the temperatures in the surrounding. Means if a heat detector, you must have seen in the buildings, malls, hospitals, that round color, round shape objects which are placed. So this is something like this. Okay, these are the detectors you can see. Smoke detectors, heat detectors, and manual call points. Manual call points, you break the glass in case of fire. Smoke detector, through this window, the smoke goes inside and this gets activated. Heat detector, it sees the temperature. If the temperature is some 57 degree to 80 degree, it will activate. So in case of in normal conditions, temperature may go up to 55 degree or whatever, but environmental temperature will not rise to that degree. That ground is normally at higher temperature. Okay, so what will happen? So this thing, like in a distribution board, these components wiring get connected to a control panel. Now there is a word written over here as mimic panel. Mimic panel is mimicry, means it replicates whatever is there. Like control panel will be for one floor, one part of the building, control panel will be there. Now, but in case of fire, you cannot reach that place until you know that fire is here. So there has to be one mimic panel which is there at the entrance point of the building or somewhere in the security area, it will indicate fire. So that person who is responsible for security of the building will immediately come to know that there is a fire somewhere. Now, nowadays, these control panel, mimic panel are integrated. Mimic panel is integrated into a digital display where straight away you can see where the fire is. So I'll skip this mimic panel, repeater panel. These things are nowadays digital, like TV, like screen. It is there in security room. Now, as you must have seen, I will I am equating it with electrical wiring. In case of electrical wiring, there are fans, lights, small power points, some 8 power points. They are being connected to a distribution board. Here, they are the components which are there on ground. They draw very small current. This is supplied through a battery bank. Normally it is 24-volt DC. So this is now area is divided into zones. Each zone will have certain number of detectors. So they will be terminating onto this control panel. So if I see this, you can see on my slide, there is an output device. Output device is your smoke detector, heat detector, like that. It is getting connected to, sorry, input device is your smoke detector, heat detector, which is providing supply to this control panel. Control panel gives signal to output devices. Output device is your siren, hooter, or some display. So that will tell that there is a fire, so you have to act. Now nowadays the LED type of control panels have become obsolete. Still, they are still in use, but nowadays more stress is on digital displays, right? So this is, I will not discuss. It is little complicated. Whatever I am saying, wherever you have got any confusion, you can always ask me. Now, next is air conditioning and ventilation. Air conditioning, central air conditioning is a big topic in itself. So here I'm skipping this. I am considering you have a building where you have in individual rooms or houses, you have window ACs, split ACs. You can also have package ACs, central ACs, and ventilation system. So this air conditioning being a subject in itself. So what we have as MEP engineers, we have to suppose I am associated with a construction company. So I will ensure that my ACs are at least 4-star or 5-star, which is the norm given by the government. Government has given energy conserving norms, which are called Griha norms. Like they stipulate which kind of. Now, one thing I want to tell in case of split AC. So if those who are not electrical should appreciate, supply is coming from my MCB. It goes to outdoor unit. From there, it comes to indoor unit that inside I can see that split AC. So that size of wire matters. Now here it is ventilation system. Ventilation system, you can see it's a basement where my cars etc. are parked. So there is a blower which is blower is provided at different places. But here what you are seeing, these ducts, they are catching the smoke or foul air, and this will be pushed outside into atmosphere. Now, for this, fans like this are used. These are axial fans. This from inside, this is throwing like our exhaust fan in our house. These are big exhaust fans. There are centrifugal fans also possible, which something in our electric chimney which is there. So these kinds of fans are provided there. So both kinds of configurations are possible. One thing I want to mention here, you see this is catching foul air. So here it's a parking. So in this parking, this duct is coming right up to ground so that it catches vehicle exhaust and throws away. You might have seen these kinds of jet fans. These are there in tunnels or in the parking lots of shopping malls. So these are less bulky, pleasing to our eyes, and they can be used. They are as effective as that other kinds of system or which are providing with duct. Lifts, I will just mention lifts. They conform to certain IS. Lift can be with a conventional machine room which is provided on the top, or nowadays that complete machine is provided on the top of lift itself. So there is no requirement of any machine room there. Lifts are categorized as per their use. So they can be passenger lifts, goods lifts, or dumbwaiter. Dumbwaiter is maybe a new word for you. Passenger lift, goods lift, easily understand. But what is dumbwaiter? Dumbwaiter is provided in hospitals or in
Hotels.
shop, right? So
In hotels, sir.
pardon?
Dumb waiters are provided in the hotels also.
In the hotels also, correct. So dumb waiter word has come from that waiter only. So it sends the food and other items onto the main floor. Now these speed of these lifts is generally small, 1 to 2 meter per second, so that there is no jerk to the person using that lift. Outside, when the lift is 50, the building is 50 storied or 100 stories, the different speeds are there, then speed control arrangements are there so that the people do not get G effect which who are using the lift. Now fire lift is related to firefighting. Means in case of fire in a multi-storied building, these lifts are not to be used. There will be only one lift which is operational, which is categorized as fire lift, will be used only by firefighting people. Nobody else can use. Now this fire lift is connected to generator. Usually when there is a fire, electricity will also go. So this lift is connected to DG set supply. The moment DG set supply comes into being, this lift will become operational. Then ARD, automatic rescue device. What is that? It is a control battery provided in the machine room which controls the brake. In a lift, normally when supply is not there, that brake is always applied in default mode. When we give a command to that lift, that supply comes into the brake and it releases the rope. Then the lift is free to move. In suppose there is a power supply failure, what will happen? That brake will immediately be applied onto the rope. Now lift cannot move. Now I am using that lift during that time. I get trapped here. So there is an ARD, automatic rescue devices, where from the Battery bank, it provide supply to break for a short time. Now you must have seen a pulley. अगर हम if you see in a lift well, you always see some wires going up and down, right? These wires are normally pulleys, that same thing which we use in wells. Now whichever side load is more, so in case of a lift, what happens, uh, there is a load provided in these wires and equal to the weight of the lift carrying capacity. Now, if depending upon the load, the rope may be going up or down. So, what ARD will do, it will provide supply to that brake for a short time, and it will allow lift movement up either upwards or downwards. The moment lift reaches at the floor level, that sensor senses and door is opened. That is the end of the function of ARD. Now the person can come out. Okay, like now these are complicated how zoning flow, traffic flow is controlled. I'm closing lift part here. If there is any question, we can have in our question answer session. I'll answer your queries. Now, lightning protection. Lightning protection is very important, especially in coastal belt like Andhra and other places. There is a lot of lightning. If lightning, so our buildings must be provided with sufficient protection. How that protection will be provided? Lightning catches the live part, highest live part first. Suppose that there is a lot of energy there in lightning, that lakhs of kilovolts, that energy is coming. Wherever it finds a path, there a lot of heat will be generated and everything will be burnt. So here in lightning protection, we provide some exposed conductors at the highest point of my building. Now here on the right hand side and on the left hand side, you can see some features of the building. So my conductor open to sky is following those features. So it must be there at the highest point. Now you might have seen there's some vertical rods are there. Vertical rods are finials. They are there. They're at least about 60 centimeter. So they are highest point in the building. If lightning strikes, it will be caught by this finial, taken by these conductors finally into the ground. There is a earthing photo which I had shown on my earlier slide. That same kind of earthing is there. It will take this energy into earth without affecting our system. Now these set of conductors are also connected. This is the floor level. Underground they are interconnected so that they provide path of least resistance, right? So this is that building. You can see the finials, you can see the features. Every feature is, now IS says these separation, if it is that roof is more than 9 meter, so every 9 meter there will be a finial like this. So there will be a mesh. Suppose the building is large, then there will be cross conductors like this also. Now these conductor will be insulated from the building. There is a porcelain seat which is there on which these conductors are there. What kind of conductor it will be? It will be normally aluminium flat conductor, 25 centimeter by 3 centimeter. These kind of conductors are there. They will take my energy into ground. There is one more aspect which are called cone of protection. With the highest point in the building is this. Now there is a cone, imaginary cone which is there. It will provide protection in that area. Now there is a finial which is close to boundary of the building. So this cone is coming up to here. This means if there is a multi-storied building, all small single-story structure will automatically get protected. Normally, IS that says no protection, lightning protection up to 3-4 storied building, more than 15-meter height, then these lightning protection will be there. Or if your building has is got certain critical load, then you provide this. Now, external water supply. Water supply is coming from Public Health Engineering Department. What important is there for MEP engineer is that supply is coming from outside. It will go into a tank. Now the tank, water tank has got two parts. One is fire tank part, other is water storage for drinking purposes and use purposes in the building. So first the water will flow into fire tank, overflow will go into water storage tank, which is in turn connected to different pumps or different things. Now, why this arrangement is there? Because water inside your fire tank should remain fresh. Water in the water storage tank will get consumed every day, but not in fire tank. Fire tank will be used only in case of fire. So this tank is connected only to firefighting lines, right? Next, we come to firefighting. Firefighting, this is a table I have taken from the IS code. It is giving different kinds of building, what kind of arrangement will be there. There are fire extinguishers, fire hose reel, now these things will come. Now these are different kinds of fire. So fire can be in my paper, in my clothes, in my wiring system, or maybe if some fuel store is there, fire is there. So different kinds of fire are categorized like this. For different of our normal day-to-day use, we use dry powder type of fire extinguishers, foam type or CO2 type. Basically, eh, how they act, they reduce the availability of oxygen in the vicinity of the fire. So when oxygen is not there, that fire cannot sustain. So these extinguishers are there for small fires limited to one small portion of the building or room. So these are extinguishers of different. Now, suppose there is a substation. Now, it cannot fight fire with small extinguisher like that. So there will be a manifold like this. Earlier, halon gas was being used, which was fighting fire in an electrical substation. But now that halon gas being CFC has been banned, so different kinds of gases have come. Now these are sprinklers. Sprinklers are two types. Water sprinklers, they are connected like sprinkler. Suppose it's a hospital. A patient is lying in the hospital. If there is a fire, that patient cannot run away suddenly. So what will happen? That fire alarm system will sense there is a fire, will give intimation to firefighting system. Those firefighting pumps will get switched on. They will send water with pressure to different areas. Now from this nozzle, water will come. Now there is a word I have used here, deluge fire suppression. Now you remember that basement where parking many cars are there. Now this area is full of petrol and other things, so we do not want fire to spread. If the fire is there in some vehicle, that's a different story, but fire can be there in wiring and other things. Suppose some garbage is there, garbage can catch fire. So what will happen? These things, these deluge fire, they, without waiting for the fire alarm, they will sense fire locally and they will burst, and immediately they will throw water in this. Here in India, it is not common, but outside there is a garbage chute where from the multi-storied building, they throw the garbage bag into a room down below, given in the basement or ground floor. Suppose there is a fire there, it is not being attended. No person is available to see that. So such fires, automatically these deluge firewalls will get operated and they will quench the fire. Now, what is happening in our firefighting room? Firefighting room will have three kinds of fire pumps. One is main electric driven pump. Suppose electricity is not there, then there is a diesel driven pumps. Then there is a third small pump which is called jockey pump. So these main pumps will maintain a pressure of 5 kg per centimeter square in our firefighting lines. Firefighting lines will be there all over the building. So now there may be small leakages or something like that. The moment there is a fire, we connect a fire hose there. So water should gush with pressure. So this jockey pump will ensure that pressure is maintained at 5 kg per centimeter square. Its work is only to maintain pressure in these lines, not to throw water in bulk quantities. Now these are yard hydrants. You must have seen it outside in our buildings, in the near our staircases. These fire hoses like that is there. Then these are the outlet valves. We will take out this hose, connect it here into the wall, open this, then water start flowing. This is what we see in the hose cabinet. There will be uh, hose like this. They are two. Each hose is 15 meters. So this can fight fire up to 30-meter distance. Right? There are two. They will get connected. So this is residential areas. Now, in a multi-storied building, the fire goes like this. Now, there are two words, wet riser and dry riser. What is riser and what is dry riser? Wet riser is when it is connected to a pump room where the pumps are there, pressurized water is available in this manifold. So the moment there is a fire, you connect this, water is available at high pressure. But in case of dry riser, it is only a pipe system which is connected. Suppose there is a fire, you call the firefighting vehicle, it will connect from outside yard, it will connect into this. Then whichever floor the fire is there, that fireman will come and fight this fire. So here, to keep this line full, there's a small tank provided on the rooftop, which will keep this line full, so that the moment firefighting vehicle has come and has connected, water is instantly available at the desired location. Now, deluge I have already discussed. Nowadays, a word which is used very much in Now you consider an architect. Architect used to prepare drawings on a piece of paper or tracing sheet. Now what will happen? This is older method. Then came AutoCAD. AutoCAD was doing the drawing of the same thing but on a computer system. But AutoCAD will provide only 2D drawings, means which you can see on the paper. Now, there is a requirement in a building. You need data in three-dimensional form. Three-dimensional form, so that you see the plans, you can see the elevations, but you can always see where my firefighting line, air conditioning line, and wiring line will cross the structure or the building, various components of the building. So this is BIM. BIM is building uh, building imagery module, right? So this BIM will be there. BIM is a subject in itself. So BIM is, it's only to tell you there is something called BIM which is extensively used these days in our constructions. So this BIM will create some module which you can see in your computers, and they are available till eternity. They are produced when there was nothing on ground. So an architect has created these drawings, created a system, has created a 3D image of that. Now building has been built. Building was built some 20 years back. Some cracks have started developing. So still that BIM drawing is available to see what, then that structural engineer will come and check these drawings. So these are different. Then there is another thing called building management system. Now this thing, without this you cannot survive. Now you have a multi-storied building which will have heating, ventilation, lighting control, fire alarm, firefighting, security, CCTV, lift control, pumping system, water tanks level, irrigation system, electric meters, water leak detection system, split units. VFD is basically a part of your air conditioning system. Now, the earlier these things, these different systems will have their dedicated control system within themselves. Now, everything has been integrated into a building management system. Now, building management system will immediately tell you which is left, which lift is stuck somewhere in which block and which at which floor. So these informations are available in your control room. They will tell you, CCTV feed will come. It will immediately tell you where breach has taken place. So firefighting, where the fire is there, like that. Now building management system, it gets connected to different utilities, different of the building. There is a PC which is available. You can have one or series of PCs for different services. Now this BMS, I will not go into too much of detail. Other than what all facilities are there in a multi-story building, there will be PA system, cable TV system, access control system. Like you enter a premises, there is a guard sitting on the main gate. So there is an access control. Till he gives signal, this barrier will not be lifted. Same way, a building is having 100, 200 or 300 houses. Here, cable, having loose cable TV wires is ugly. So there is a wiring which is done during building construction stage. So that is will carry cable TV wire. PA system for So I will discuss these facilities. Now we are moving towards question answer time. You whatever I have discussed, I have tried to keep it little simple. I can make it complicated, but then my entire audience will not be able to listen to it with interest. So here a lot of electronics is which will tell me where all what my things are there. Right now, I am finished. I I invite questions from you. If you have got any query, whatever I have discussed so far, you can ask. Is there any query from you?
Thank you very much, sir, for the valuable information and valuable knowledge.
I'm grateful to all of you who have listened to me with lot of patience. And if you have got any queries, please leave it in the comments, and they will be taken care of during future. So something were very elementary, but what happens? I have seen in my service life people having 20-30 years of service, they get confused with single phase and three phase. Single phase and three phase paper may it looks very good, but when it comes to on ground, my ultimate engineer is that electrician. If something happens in my building, only the electrician knows where from that supply is coming, how it will the fault will be fought. I'll tell you my own example. When I was in my class, first year of my engineering degree. In my study room, my tube light stopped working. So what was there? So I immediately I went to my father that please call an electrician, that tube light is not working. He immediately said, you are an electrical engineer, you find out what the fault is and try to repair it yourself. Now, I didn't, as electrical engineer, I did not know how my tube light burns. I have never bothered to see the electric circuit from where supply it is getting into my room. Then I opened the book, found out the circuit system which controls the tube light. Then what I found, the choke of that tube light was non-functional. I went to the market, brought a choke, connected it in the same way as it was there in my original fitting, and it started working. But that lesson I learned, that we are not practical engineers. Slowly we will move to uh, artificial intelligence, where things will be done in a click, but we will forget the basics. Ultimately, these electricians, plumber, and mechanics, they are going to the lifeline of our world, right? With this, I close. I thank you all for all your patience.
Good
Thank.
afternoon, everyone. Sorry to disturb you, sir.
Uh,
Uh,
yes,
I'm audible.
yes, you are audible.
Sorry, sir. I would like to respectfully invite Dr. P.R. Saroop, NHECI, to share a few words with us. Dr. Saroop,
Sorry to interrupt, Mr. Singh. Can I ask a small question to Mehrotra sir?
sir, please.
Yeah. Sir, Mehrotra sir, good morning. We run through with a in-depth, insightful things on MEP aspects, which are basically playing a vital role in commercial IT parks. So, with respect to variable frequency drive,
Yeah.
getting used in elevators. We would like to few things about it because since COVID-19, the
Hmm.
elevator speed has got enhanced. Moreover, the
Correct.
ionic antibacterial systems are also getting implemented. So in
That's
terms
right.
of achieving sustainability concept by providing VFD for optimistic use of electricity to carry the passengers as well as providing antibacterial functions in elevators. So if you will put up 2-3 lines on it, it will be a great thing for us.
I will try. I would like to amplify this. VFD is variable frequency drive. It has got nothing to do with that bacterial thing, right?
Yes,
Bacterial
true.
thing is environmental thing. For that, some filters and things like that will be used. VFD is only an energy saving device where you, in case of induction motor, if you must be remembering, it works synchronous on the concept of synchronous speed.
Yeah.
Asynchronous speed.
Yes, sir. Yes, sir. Understood. Yeah.
Yeah.
Asynchronous speed.
Can you see me?
Yes, sir. We are able to
Ah,
see you.
yeah. Now, VFD is variable frequency drive. Suppose on 50 hertz, the motor runs at 1500 RPM or little less, whatever. So that RPM, that synchronous speed will change. Suppose I want to use this motor at a slower speed, then I will put some regulator in the circuit. It will make sure that some energy is getting wasted. So if I use VFD, it will ensure that motor is working at its full efficiency. Now next year, that environmental thing will be used in closed premises, not in any open building like that. Suppose it's a hospital or it's a clean room somewhere. Now that entire thing is centrally part of central air conditioning system. I will provide some HEPA filters in my AHU duct. So that will filter the bacteria and viruses so that there is no problem to the occupants. Anything else, Mr. Kulkarni?
Yeah, yes, sir. In terms of AHU concept, I have understood your point. But in
Hmm.
terms of elevator, to maintain the internal ambient temperature condition with the required disinfectional characteristic, a concept of ionic heating is being introduced since
Correct.
2020.
That's right.
So that unit is getting mounted on the top of the car, and while having 2 to 3 air exchange cycle, it will ensure that the first occupants moves out of car. While entering into the second occupant, the ionic synchronization will ensure that a small passage of hot heat
That's
air
right.
will be passed through the car, and it will
That's right.
ensure that bacteria being carried by passenger one will be automatically get killed, so that it will not have impact on second occupant.
Very aptly explained by you. Actually, this all is part of ventilation system. I
Ha ha
wanted to cover many things, so it is not, because if I start talking on this, I need
ha.
at least 2 hours for this discussion itself. So, but
Yes, sir.
your
Yes, sir. Correct.
point
Yeah,
is
sure.
correct and well taken.
Yeah, yeah.
Nowadays, these facilities are provided in all lifts, so that when there is a movement, there is always a stale air inside my shaft. So it
Ah,
will make sure that person in using the lift is safe, right?
exactly. Yes, sir. Yeah.
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 Thank you.
Sir, with respect to your expertise and involvement into the engineering career or
Hmm.
professional practices, I would like to request you to conduct another session at least on next Sunday, which will speak about more about on IBMS, because nowadays, as you rightly chalked out, all the systems are in place, but unless and until you will not have integrated building management system, you will not be able to control a complete premises. Construction of a commercial IT park or a commercial premises is a separate ball game, but controlling all the functions at a single days as a BMS operator is also a different ball game, and it's a very much vital
Yeah,
role
yeah.
into the industry. So if you will
I
be
will.
able to spend at least half an hour during your next session on IBMS part, and a thoughtful suggestion being an electrical engineer on how HT power get transmitted to a building via substation to RMER to three-pole moment structure, three-pole structure, then transformer, then LT panel room, and then cascading down to all the floors by means of air insulated bus duct. So that
I
kind
will
of
definitely do
electrical.
that.
Yes, sir.
What I will do in my next session, I will cover other things in short. I'll
Yes,
take
sir.
these two topics so that what happens, like what is there in my switchyard, generally
Hmm.
we ignore. I have
Hmm.
concentrated whatever is there inside the building, but
Hmm.
next
Hmm.
in my next discussion, I'll try to cover these two aspects in little detail.
Yes, sir.
So I'll be in touch with Mr. Yograj. But
Yeah.
whenever my next session is planned, I'll make sure these things are covered. Right?
Okay, sir. Great. It will be a great help to all of budding engineers into the industry, and people like you always inspires us. Thanks
Thank
a lot
you.
for your expert advice, sir. Thanks a lot.
Thank you.
Sir, one more thing. Can we have
Yeah.
a session on integrated multi-utility tunnels, which are quite popular in other countries, and India is not very much popular in India, but one or two places have made those, and that is for the townships, etc. Like for the Gift City in Gujarat, they
Yeah.
have tried it, and I think it is working also. Even in Delhi, Connaught Place, they tried something, but
Hmm.
I think that I don't know how much successful they are. But in other countries, they are quite successful. So, can you cover those aspects? I mean, this
Sure, I'll do that.
particular aspect.
Sure, I'll. As your query is there, I will simply say you consider a jetty where the ship or small boats are being parked, right? Now, what will happen? You see only a floor. Now it requires water, electricity, firefighting, everything they are required on that floor. That nothing can be there on the top. So now
Yes,
that inside below jetty there is a concrete box. Now it
yes,
will carry all the services. When I'm speaking from Delhi. Delhi, there are a lot of tunnels have been made, like Dwarka Expressway and other places, where a lot of utility services are also. So I am driving my car, but at the same time, my attention is towards those services also. So sometimes you find you are feeling sleepy. That means the ventilation system is not working properly. When there is a lack of oxygen, you start feeling sleepy. So
okay.
those things are there, but it will be a topic. It will. I'll in my next this thing I'll cover in short, but it is not possible to cover it in detail. But what you people have told, IBMS itself is a 2-3 hours job. Substation configuration will be easy. I'll cover in 5 to 10 minutes. There is no problem. That same way these integrated I will touch upon it.
So maybe if possible, a whole session can be for this MUT, because one thing is we have separate ducts underneath the road,
Yeah,
and one
yeah.
thing is they are human access. I mean, human access is
Access is
possible,
also there. Yes,
and
correct.
all the repair, maintenance, O&M can be done without digging, without disturbing the surface or the road, and everything can be done inside itself. So
Yes,
I just want to understand how they are laid, what is the network, and how the crossings or the uh, uh, at the junctions and the T junctions and crossings, how the network runs. So
sure.
yeah, if
I'll
possible,
I'll
yes.
also update myself, and whatever you are saying, we'll try to cover in my next session. Yeah, or maybe next few sessions. Whatever
Yeah,
is.
yeah, next few sessions. So that will be a great help. Thank you, sir. Thank you very much.
Welcome, ma'am. Welcome. With this, now I am leaving for the next speaker.
Hello, hello, hello.
Yes, you are
I'm
audible.
Yeah, you are audible,
Yes,
Mr.
you
Singh.
are audible.
Yes.
Sir, on behalf of everyone here, I would like to extend our sincere thanks to our speaker for the insightful and inspiring presentation, and to our wonderful audience. Thank you for your active participation and thoughtful engagement. Your presence made this event truly meaningful. Thank you, everyone.
Thank you. Thanks a lot.
Thank you. Thank you, Mr. Yogurt.
Thanks, everyone. Thanks a lot.
पहले बंद कर दे हाँ जी बंद है ना मेरे बंद कर दे रुक जाओ